بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 4.8 Optimization. The aim of this section to find optimal values, maximum or minimum, for a function, objective function, when relation between some of the variables involved is given, which is called constraints. So the aim of this section to find the maximum or minimum for an objective function. And we will use here the constraints to help us to find these variables. السكشن هذا يتكلم عن الاوبتمايزيشن اللي هي كأنها نفسها التمثيل، نجيب الماكسيمم والمينيمم. دائما الأسئلة تكون find the maximum or find the minimum. الفانكشن هذا نسميه objective function، وطبعا لازم يعطينا إنه نحدد مجال الفانكشن هذه، إيش العلاقة بين المتغيرات، الفانكشن إيش لازم تكون وهكذا، فنسميه هذا constraints اللي هي كأنها نفس القيود، إنه محدد لنا إنه من كذا إلى كذا، مثلا إنه ضرب المتغيرات يساوي كذا أو مجموع المتغيرات يساوي كذا وهكذا. بنشوف examples, but first let us say what is the guidelines to solve any problem in this section. So guidelines for solving optimization problems. First, you need to read the problem slowly, then read it again. اللي هو نقرأ السؤال أكثر من مرة. Then draw a picture when possible, keep it simple. إذا ممكن إن نسوي sketch للسؤال this will be helpful، يعني يكون أفضل. Introduce variables in your picture if there is one and note any constraint between the variables. بعد ما قرينا السؤال نرسم picture أو sketch للسؤال إذا ممكن إن نمثله، نحدد عليه ال variables اللي هي المتغيرات، ونحدد الأشياء اللي معطلنا إياها. Using all necessary variables, set up the objective function. If more than one variable is used, then employ the constraint to reduce the function to one variable. بعد ما حددنا ال variables نكون العلاقة بين المتغيرات اللي نحن جبناهم، فنسميها هذا objective function. إذا كانت الفانكشن اللي سويناها أو الريليشن كان فيها أكثر من متغير واحد، نعيد كتابتها بحيث أن نحولها إلى function of one variable. ليش function of one variable؟ أساس إنه يسهل علينا عملية الحل. فإذا كانت الفانكشن اللي جبناها عبارة عن function of two variables نحولها إلى function of one variable، نستخدم constraint. Then note the interval on which the function is defined. Determine all critical numbers. لازم نحدد مجال الدالة وبعدها نجيب ال critical number عن طريق الاشتقاق. If the objective function is continuous and defined on a closed interval a to b, then test for endpoint extrema. If the desired extremum does not occur at an endpoint, it must occur at the critical number in the open interval a to b. بعد ما جبنا الفانكشن الحين نشوف الدومين مال الفانكشن ونطلع طبعا الكريتيكال نمبر. نعرف إنه الأبسولوت ماكس والأبسولوت مينيمم تصير يا عند الإند بوينت اللي هي الفترة اللي عندنا أو عند الكريتيكال نمبرز. فبنجيب قيمة الدالة عند الكريتيكال نمبر، بنجيب قيمة الدالة عند الإند بوينتس اللي هي الA والB الفترات. لكن في حالة إنه if the object function is defined on an interval that is not closed, then a derivative test should be used at each critical number in the interval. فرضا إنه الفانكشن كانت defined في open interval، فعلى أساس نحدد اللي هي الماكسيمم والمينيمم بوينت، هنا لازم نستخدم الفيرست ديريفاتيف تيست، لأنه بتكون الفترة open فما بنقدر نحدد يعني إيش وين الأبسولوت ماكس وين الأبسولوت مينيمم، فبنستخدم اللي هي عن طريق الكريتيكال نمبر الفيرست ديريفاتيف تيست، نشوف قبل الكريتيكال نمبر وبعد الكريتيكال نمبر إيش هي إشارة الديريفاتيف، نحدد على أساسها هل هي ماكسيمم أو مينيمم. So here we go, we have to find two non-negative numbers. So if we assume that the two numbers, for example, x and y, so this is our two numbers, whose sum is 5. So whose sum is 5, that's mean x plus y should be equal 5, such that the product, so this is, we can say about this one, x plus y is equal to 5. This one is concentrate because we are given that the strict here the sum is equal 5. So this one is concentrates. Also such that the product of one and the square of the other is as large as possible. So the product of one, if we said for example the product of one, so p, for example pxy, product of one, which is for example x, and the square of the other. So the square of the other, x squared. This is as large as possible. So we want this result to be as large as possible. So we have two variables, x and y. X plus y is equal to, should be equal to 5. And x multiplied by y square will be large as possible. So this one bxy will be, we called objective function, because this is the relation between these two variables also. So this is objective function. But since we have two variables, we can rewrite this information as a function of one variable. So since the sum of these two functions, the sum of these two variables, x plus y is equal to 5, we can choose the first variable to be x. So the first variable will be x, and the second variable will be 5 minus x. So rather than using x and y, we will use the variable, the first one is x, and the second one is 5 minus x. Why we choose 5 minus x? Because we know that if we add these two, we have to get 5. So let us add these two. So 5 plus, sorry, x. So here we have x plus 5 minus x. If we add this variable and this variable, we'll get x plus 5 minus x. This will give us, it is equal to 5, because this x will go with minus x. So the first variable will be x, the second one will be 5 minus x. Now our function is p. X will be equal, the first one is x, the second one will be 5 minus x all squared, because we replace this y by 5 minus x. So now we have convert this one from function of two variables to function of one variable. So now we have p of x will be equal, we have x multiplied by 5 squared, so this will give us 25 minus 10x minus plus x squared. If you put it all together, so this will give us x cubed minus 10x squared minus 25x. So this is our function b of x. So we have our function, we need to find the maximum and the minimum point for this function. Since the question said x multiplied by y squared should be large as possible, so just we need to find what is the maximum point for this one. For sure x and y should be in where x and y here should be both from 0 to 5. Why from 0 to 5? Because the addition between these two numbers cannot be exceed 5. So if one of them is 0, the second one should be 5. If one of them is 1, the second one will be 4. If one of them is 2, then it will be 5. It will be 3, and so on. So these two numbers cannot exceed this interval from 0 to 5. So we have our function b of x, and the domain of this x will be from 0 to 5. Just we need to find the derivative, then we check the function at 0, at 5, and at the critical number. So p prime x will give us 3x squared minus 20x minus 25. So p prime is equal to 0. That's mean 3x squared minus 20x minus 25 is equal to 0. Now if we try to solve this function for x is equal to 0, we can factorize it. So it will be 3x minus 5 multiplied by x minus 5 is equal to 0. From here we will get x is equal 5 over 3. From here we get x is equal 5. So x is equal to 5 is one of the endpoint. X is equal 5 over 3, it will be 1 point something, so this is in the interval. So we'll take this one as a critical number. So we'll choose this one. 5 is in the endpoint, so we'll choose it for sure. So now let us evaluate the value of our function at x is equal 0, at x is equal 5, at x is equal 5/3 to choose the largest point. So we need to evaluate what is the value of b0, what is the value of b5, what is the value of b5/3. So we go to the function b, we substitute here in this function to know what is the absolute maximum and what is the absolute minimum. So for b0, if you go to this function, replacing any x by 0, we will get here 0 multiplied by 0, and here we have 0, so all of this will be 0. So at b0 we have the value is equal 0. So b0 is equal 0. Then for b5 we go to this function, replacing any x by 5. This will give us, it is equal to 125 minus 10 multiplied by 5 squared minus 25 multiplied by 5. This will give us also 0. b5/3, so we'll replace any x by 5/3 here, and we will get it is approximately, it is equal to 18.52. So from here the highest one is 18.50, has an absolute max at x is equal 5/3, where f5/3 is equal 18.52. So our x is equal 5/3, and we said that y is equal, or the second one will be y is equal 5 minus 5/3, and this will give us, it is equal 10/3. So the two numbers are 5/3 and 10/3. So example number 1, when air resistance is ignored, the horizontal range r of projectile is given by r theta is equal to v0 square over g sine 2 theta, where v0 is the constant initial velocity, g is the acceleration due to gravity, and theta is the angle of elevation or departure. Find the maximum range of the projectile. And here we have picture for this question. So here we have a range of the projectile. It is given by r theta is equal v0 square over g sine 2 theta, and we are asked to find the maximum range of the projectile. So we need to find what is the maximum r. So we need to find theta, that's make this r is the maximum point. So first of all, if we see our function or the objective function, it is r theta. Sorry, so here we have r theta. It is equal v0 square over g sine 2 theta, where theta should be between the range. So theta represents this one. So theta should be start from 0 until pi/2, because it cannot exceed pi/2. If it is more than pi/2, so the distance will be here less. So we will take theta is from 0 to pi/2. So to find the maximum, we need to find r prime theta. So we differentiate this one with respect to theta. So v0 square over g will be constant. Derivative of sine 2 theta will be cosine 2 theta. We need to multiply by the derivative of 2 theta, which is 2. So to find the critical number, so r prime theta is equal to 0. That's mean v0 square over g cosine 2 theta is equal, here we have 2 is equal to 0. So since this constant, so that's mean cosine 2 theta will be equal to 0. So from here 2 theta will be equal, because here we have cosine 2 theta is equal to 0, so this will give us pi/2 in this interval. But we want to find theta, not 2 theta, so we'll divide by 2, so that's mean theta will be equal pi/4. We need to check, is pi/4 in this interval? Yes. So we can take this one. So this one is in the pi from 0 to pi/2. So we can take this one as a critical number. Because our function is continuous and it is defined for any value from 0 to pi over 2, so we can test now the function, the maximum, the minimum for this function. So we need to evaluate R0, we need to evaluate R pi over 2, we need to evaluate also R pi over 4. So for R0, that means we go to the function R, replace any theta by 0. We know that sine 2 multiplied by 0 will be sine 0, so sine 0 is equal 0. So all these terms will be equal 0. R pi over theta, so that means we need to replace theta by over 2. So 2 multiplied by over 2 will be pi. Sine pi will be 0, so all these terms will be 0. For pi over 4, so we'll get 2 multiplied by pi over 4, which is pi. So, 2 multiplied by pi over 4 will be pi over 2. Sine pi over 2 will be equal 1. So 1 multiplied by v naught square over g, this will give us v naught square over g. So v naught is the velocity, g is the gravity. So that's mean the highest value here is v naught square over g. So we conclude that R has a maximum value which is equal v square over g at theta is equal pi over 4. So here we have at theta is equal pi over 4. So again from the beginning we are given that the projectile is moving in some distance range. This r we ask to find theta, where this theta give us the highest r. Our function is continuous, so we will find the critical point. We find that the critical point is theta is equal pi over 4, pi over 4 is in this domain, so that means we choose pi over 4, 0, pi over 2 to check the value of our r. So we take r0 is equal 0, r pi over 2 will be 0, r pi over 4 will be v square over g. The highest one here is v square over g, that means the function has a maximum value which is equal v square over g at theta is equal pi over 4. Example number 2, find the point in the first quadrant on the circle x square plus y square is equal 1 that is closest to the point 2, 4. So we have a circle which is x square plus y square is equal 1, unit circle, and we want to find the point xy in the first quadrant. That means x is greater than 0, y is greater than 0. This point should be close as possible to the point 2, 4. So we are looking for the absolute minimum. So for example, let us say this point is, so here we have the point xy, where we have x greater than 0, y greater than 0. Why both of them greater than 0? Because it will be in the first quadrant. That means both of them is positive. And the distance between this point xy and 2, 4 should be as small as possible. So the distance will be equal to square root of x minus 2 all squared plus y minus 4 all squared. So this is the distance between this point xy and 2, 4. If we say this one is the function dxy, so this is dxy. If we take the square root, if we take the square of this function d square xy, this will give us square root x minus 2 all squared plus y minus 4 all squared, all this one squared. So d square xy will give us x minus 2 all squared plus y minus 4 all squared. Because this root will cancel with this squared. Now the square of the distance, why we take the square? Because to simplify our calculation. يعني إذا كانت الديستانس between ال x وال y small اللي هي d، نفس الحالة بتكون d square نفس الشي the smallest one، يعني ما بتأثر في اللي هي الديستانس اللي نحنا نجيبها. فعندنا d square is equal x minus 2 all square plus y minus 4 all squared. And we are given that x squared plus y squared is equal 1. That's mean if we can replace one of them, so if we say for example x squared plus y squared is equal 1, let us take y is equal square root of 1 minus x squared. Why we choose the positive one? Because this one is y should be greater than 0, so that's why here we have y is equal root of 1 minus x squared. So now this is our function, and we can rewrite this y by this y, replacing by root of 1 minus x squared. Let us see what is the interval of this function. Since x and y, x squared plus y squared is equal to 1, that's mean both of them, x and y, should be in the interval from 0 to 1, because they cannot exceed 0, 1. So now we have our function. Let us replace, or let us first rewrite this one as a function of one variable. So we have here, so this will give us, so here we have d square xy, this will give us x squared minus 4x plus 4 plus y squared minus 8y plus 16. If we rewrite this one, this will give us x squared plus y squared minus 4x plus 4 minus 8y, or we can add 4 with 16, this will give us 20. So here we have minus 8y plus 20. So minus 8y plus 20. Now we know that x squared plus y squared is given by 1, so we can replace this one, so it will give us 1 minus 4y minus 8y plus 20, so it will be minus 4x minus 8y plus 21. This is d squared. If we need to rewrite our function as a function of x only, so write for example this is d of x, this will give us minus 4x minus 8. We replace y by root of 1 minus x squared. So this 1 minus x squared, sorry, here we have 1 minus x squared, it is power half, plus 21. Now to find the critical numbers, we need to differentiate this function. So d prime will be equal minus 4 minus 8. The derivative of this one will give us 1 over 2 multiplied by 1 minus x squared power half, and the derivative of 1 minus 2x squared will be minus 2x. The derivative of 21 will be 0. So now we have d prime is equal minus 4. We can cancel these two with these two, minus with minus, so this will give us plus 8x divided by root of 1 minus x squared. If we want to rewrite this one again, so we need to multiply this one by root of 1 minus x squared. So it will be minus 4 root of 1 minus x squared plus 8x divided by root of 1 minus x squared. To find where the derivative is equal to 0, so d prime is equal to 0, that's mean minus 4 root of 1 minus x squared plus 8x will be equal to 0. So that's mean root of 1 minus x squared will be equal minus 8x divided by minus 4, which will give us 2x. So if we squared both sides, 1 minus x squared will be equal to 4x squared. Moving this squared to the other side, so 1 will be equal 5x squared. So that means x will be equal 1 over 5, and we need to take the square root. So x will be equal square root of 1 over 5. We didn't take plus or minus because x is restricted to be positive. So now we have the critical number square root of 1 over 5. It is inside the interval. So this one is inside the interval 0 to 1, so it is a critical number. So now we have just only one critical number. We need to check the value since our function, this function is discontinuous. So we need to check the value at the end point and at the critical number. So we need to evaluate D0, we need to evaluate D1, we need to evaluate D square root of 1 over 5. So we go to the original function, which is D, substitute x by 0. So here if x is equal to 0, this part will be 0, this part will be minus 8 plus 21. This will give us 13. So here we have 13. If we replace d by 1, so it will be minus 4 minus 8. This one will be 0. So minus 4 plus 21, this will give us 17. So here we have 17. If we replace x by root of 1 over 5, so it will be minus 4 multiplied by root 1 over 5, minus 8 multiplied by 1 minus 1 over 5 power half, plus 21. This will be approximately is equal 12.01. Since we want the closest distance, so that means we need the minimum point. Here 13, here 17, here 20. So this is the absolute minimum. That means the function has or the distance will be the closest distance if x is equal. So from here we conclude that x will be equal root of 1 over 5, and we know that y will be equal square root of, since we said here y is equal square root of 1 minus x squared, so this will be 1 minus 1 over 5. So the y will be equal to root 5 over root 5. Substitute here 1 minus 1 over 5 and take the square root. So the 2 points are, so from here we conclude that the 2 points are x is equal, we can rewrite root of 1 over 5 as root of 5 over 5, and then we have 2 root of 5 over root of 5. So this is the closest point. Example number 3, a rancher intends to mark off a rectangular plot of land that will have an area of 1,500 meters square. The plot will be fenced and divided into 2 equal portions by an additional fence parallel to 2 sides. Find the dimensions of the land that require the last amount of fencing. يعني نحن عندنا rectangular اللي هي أرض بشكل rectangular، نريد نسوي لها إطار اللي هي عن طريق الفنسنج، نضيف إطار أو نفس ما نقول سور للمنطقة هذه. طبعا السور بيكون على الحواف بالإضافة إلى أن نريد نقسمها إلى قسمين متساويات، يعني بنسوي واحد إضافي هنا. الاريا اللي عندنا 1500 متر سكوير، نريد اللي هي أقل dimension، أقل قيمة للإكس والواي بحيث أن التكلفة تكون أقل least amount of fencing. إذن هو معطينا x multiplied by y, which is the area is equal 1500 and the dimension will be اللي هو المحيط. المحيط طبعا بيكون هنا عندي y، هنا عندي y ثانية، هنا عندي y ثالثة، إذن بيصير 3y plus، هنا عندي x وهنا عندي x، إذن 2x plus 3y اللي هو المحيط. الx والy بما أنها تمثل الدايمنشن أو تمثل اللي هي أطوال الضلع، إذن بتكون الدومين مالها from 0 to infinity. طبعا 0 to infinity open interval. فالحين to solve this question we need to make an object function. We know that x multiplied by y is equal 1500, so this is concentrate. To find an object function, we need to rewrite y is equal 1500 over x. Since we need the dimension to be the least amount, so we will take the function of dimension, which is equal to x plus 3y. We will replace y by 1000 by 1500 over x. So now to find the critical number, we need to find the derivative. Derivative of 2x will be 2. Derivative of 3 multiplied by 1500 over x will be 3 multiplied by 1500, 400 will be 4500. Derivative of 1 over x will be minus 1 over x squared. If you rewrite this one, so multiply this one by x squared, this will give us 2x squared minus 4500 over x squared. Now solving, the derivative is equal to 0. This will give us 2x squared minus 4500 is equal to 0. Solving for x, x will be 15 root 10. If the derivative does not exist, that means x squared is equal to 0, and this will give us 0. And 0 is not in the domain. So for this one, 15 root 10, it is in the domain from 0 to infinity, so this is the critical number. To check the critical number, if it is minimum or maximum, we'll use the second derivative. So finding the second derivative, that means we need to re-differentiate this one again. Derivative of 2, 0. Derivative of this one, 4500 will be the same. Derivative of minus 1 over x squared will be 2 over x cubed. This will give us 9000 over x cubed. Now we will substitute the critical number, which is 15 root 10, in the second derivative. It will be positive, greater than 0. Since it is greater than 0, that means Lx has an absolute minimum at the point 15 root 10. Why we said an absolute minimum? Because this is the only critical number in the interval from 0 to infinity. That's why it is an absolute minimum. And we conclude that at 15 root 10, the function has an absolute minimum where it is equal to 60 root 10 meter. So since x is equal 15 root 10, that means y is equal 1500 over 15 root 10. This will give us 10 root 10. So the dimension will be 15 root 10 multiplied by 10 root